Hi guys, and welcome to a quick optimization review. I know a lot of you have a test on Friday, and this is one of the harder subjects, but don't worry, it's not on your AP exam. You'll be fine. But related rates is, so I don't know how fine you'll be, but don't worry about that. Right now, I'm going to do this problem from homework, which is the normal window problem. Now, this problem, you have a semicircle. Ooh, that is a bad drawing. you have a semicircle on top of a rectangle, right? Now, the diameter of the semicircle is the same as the width right here of the rectangle. So we're going to call this distance x. We're going to call this distance y. And we know that this distance is x. Okay. With optimization, you want to have two key factors, okay? You want to have two equations. So we're going to do the first equation, which is your area. Now, your area is, most questions are about area and optimization a lot of the time. So you always want to remember your area formulas. Circle is pi r squared, rectangle is length times width, square is the size squared. Basic geometry, nothing too crazy there. So the area of this will be the area of the rectangle, which is x times y, plus the area of the semicircle, now which is pi r squared, but because pi r squared is a circle, so half of that would be the semicircle. So that's your area. So area, right? Then we have the question. Always gotta read the question. You always gotta see what they're giving you. So we have perimeter here. Now perimeter is simple, right? Perimeter is this distance plus this distance plus this distance plus this distance. Okay, so x plus y, so we have 2y plus x, right? Perimeter is equal to 2y plus x, and then you have 2y plus x, and you have this part right here from the semicircle. Now the perimeter of a circle is 2 pi r, right? So because it's a semicircle, we have half of that. Half of 2 is 1. 1 times anything is the same, so you just have plus pi r. Now r is the radius, right? Now what can we do with that r? Well, because the radius is half of the diameter, we know that this full diameter is x. So we know that the diameter, right? The diameter is equal to x, which is equal to 2r. So what we can do is that we can replace r, right? That gives us that r is equal to 1/2 x. So we can just do this instead, which is equal to xy times xy plus, 1/2 pi, then 1/2 x squared. And then down here, 2y plus x plus pi times 1/2 times x. Okay, so we have our perimeter, we have our area. Now, what do we do from here? This is where a lot of people get stuck, and where I got stuck when I did this for the first time. But what you want to do is you want to have your y, you want to move it to the front. You want to write y, okay? All right, you want to write this in terms of y, because that's equal to your perimeter, okay? Right? And oh, of course, they give us what the perimeter is, which is equal to 47. So we want to rewrite this so we have y by itself on the outside. So what we're going to do is we're going to just move this over here. So 2y is equal to, right, so negative 2y is equal to, and then we just move this over here, move that over there. So then we have x plus pi over 2x minus 47, and then we just divide by negative 2 everything, so y is equal to negative x over 2 plus, minus pi over 4x plus 47 over 2. So that is going to be your y. All right, so what we do with this, right, what we could do is we can simplify this little thing right here, right? So that's negative 1/2 x minus pi over 4x, which is going to be x times 1/2 minus pi over 4 plus 47 over 2. That's going to be y. So that's our y. Now what do we do with this y? We go up here to a, okay? And we take this a equal to x. Now, we want to have it all with one variable, right? So we want to replace this y with what we found here to be y is equal to this. So this y, xy, you replace that y with x times 1 over 2 minus pi over 4 plus 47 over 2. That's our y. Then plus 1/2 pi 1 over 2 x squared. And then after that, you want to take the derivative of this. So a prime is going to be equal to, let's do some simplification here. You know what? I don't think I should have factored this out here. I think it would have been better to leave it like that because it's easier to take that derivative. So we're going to rewrite it. I'm going to rewrite a real quick. We're going to rewrite a to make it really easy to differentiate because I don't know if you guys are going to have a calculator on your test, and if you don't, it's going to be really hard if you just leave it like this. So negative x over 2 minus pi over 4 x plus 47 over 2 plus 1/2 pi 1/2 x squared. So let's rewrite this really quick. So this is going to be negative x squared over 2. You know what? I like it like this more. Negative 1/2 x squared minus pi over 4 x squared plus 47 over 2x plus, that's 1/4 x squared. 1/4 x squared. 1/4 is 1/8 pi over 8 x squared. And then what you want to do is you want to take the derivative of this, which you just use basic power rule. So a prime is going to be equal to negative x minus pi over 2x plus 47 over 2 plus pi over 4x. Now that should be your derivative. And then once you do that, you do a prime equals to 0. You gotta find where this is equal to 0. Then once you find that, right, which, let's see, if you have your calculator, it'll be easy. If not, you just do, let's see. Okay. I hope you guys have your calculator. If you don't have your calculator, it's gonna be some tricky algebra. But from what I hear, you guys are gonna have your calculator. So let's plug this in real quick. Solve for, let's see, negative x minus pi over 2 x plus 47 over 2 plus pi divided by 4 times x. Solve for x. Okay, hold on. Let's see what I'm missing here. Oh, that needs to be equal to 0. Let's see what we get. So x is equal to 13.16. So that's our x. Now, once we have our x, remember, you're going to circle back to the top, okay? So once you find your final x there, you just want to circle back to your original function, right? So this is our area function. We have x. Oh, sorry. You want to go back to perimeter because when we found this, we found y in terms of x. Now, what do we just find? We found x. So if we have x, we can find y. So we plug in x into that, which I'm going to use the calculator for, because if you're not going to have your calculator, they're going to be easy numbers to work with in this. But if you do have access to your calculator, then this is probably, like, if you have this kind of question, you're probably going to have access to your calculator. Because if you don't, then I'll fight Cabby personally on your behalf. I will yell at her. And I'm on good terms with her, so that's not going to be good for me, but for you guys, of course. Anyway, and Morales. Actually, no, she might kill me. I don't know. Anyways, let's plug this in real quick. Sorry. I need to get to the point. This video is almost 10 minutes long. Jesus. I'm not going to be able to upload this in one part. Maybe I'll put it on YouTube. That'll be a better solution. Okay. Let's see. Solve x. Okay, so we have x. So 13.16 times negative 0.5 minus pi divided by 4. Okay, we have that. And plus 47 over 2. You don't even need the solve function for this. You just need to plug that in. And then we get our answer, which is that's going to be our y. So we're going to write that down. Y is equal to 6.584. So we found our x, our optimized x. And from that x, we calculated our y. Now that we have x and we have y, then we can go to our area function over here because it has x and y. And those are our only variables. So with that, we can find our area. So we're going to take the x and we're going to plug that in again. More calculator work. It's kind of boring, but it is what it is. So 6.584 times 13.16. So you have that as x times y, then plus 1/2 times pi times, that is not pi, that's pi times 0.5 x's 13.16, all that squared. That's not, okay. And that should give you the total area. Area is equal to 154.65. That should be the answer. But that's one specific question. Now, I could sit here all day and do optimization questions and show you how to do each individual case. But the overall method that you want to have, and this is a great example for it because I always find that this kind of question gives you a good understanding of the topic itself. You're going to get two equations, okay? One of them is going to be given to you most likely, like really easily, and the other one you're going to have to work out. In this case, you have to work out both, but it's area and perimeter. It's not that hard. Sometimes they'll give you a line on a graph, and they'll give you the function, right? They'll give you that equation for free, but then you got to relate it to some sort of area. Like I know that, for example, on this problem, right, you have to relate that equation that they give you for free. You have to relate that with, so you have to relate that with the area of that box. And you have to use your coordinates. So you know this distance is x, you know this distance is x, you know this distance is y. So 2x times y, that's your area. And then that's your y. So then you replace y with x. Take the derivative, find your x, plug that in to find y. Basically, you have x and y in a function, okay? And then you have another function that you can rewrite to give you y in terms of x, so that you can go back up here with your function that has x and y in it, replace the y with x. Then you have a function with one variable. Then you take the derivative of it, find where the derivative is equal to 0, then you take that exact x, plug it back into your function at the start, and then you're gonna get this final answer from plugging in that y and plugging in that x. So yeah, that's how you do optimization basically. You always want to start with 2, use 1 to find y, then once you find y, replace y in the other one, and then take the derivative of that, then take that x, plug it back into this to find the y, then take that y and that x, plug it into your base form. So that's optimization in a nutshell. I hope it made any sense. I hope you guys enjoyed. I hope you guys pass your test on. No, you know what? You're gonna get an A. Everyone's getting an A. And if you don't, I take personal responsibility. Sort of. Don't hold me to that. Bye, guys.